Alright, so we're going to be adding and subtracting polynomials. This is the next thing we need to do after we just went over adding, subtracting, and multiplying a little bit. Now we're going to delve into each of those separately again. So number one says the 5p squared minus 3, and we're adding 2p squared minus 3p cubed. So if you don't remember, we have to worry about what is a like term. That's how we're going to know what to put together. Right? Like x squared, x squared. So on this first one, I see 5p squared. So a like term to a 5p squared is going to have the same variable, p, and the same exponent on that variable. It's going to be a p squared. So it's not going to be that minus 3. There's no p squared there. I do see a 2p squared. Perfect. We can put them together. And then remember, pay attention to the sign here. We are adding them. 5p squared plus 2p squared. 5 plus 2, 7. Keep your p squared. Okay. We've taken care of these two. Now I see a negative 3 and a negative 3p cubed. So we have to ask ourselves again, are they like terms? Can they be combined? Well, they'd have to have the same variable. Negative 3 doesn't have a variable. So something that could be combined with it also wouldn't have a variable. And I don't see anything like that here. So, can't be combined, just gets tagged on. And now it looks like the same thing is going to happen with this, minus 3p cubed, because I don't see any other p cubes. So, he just gets tagged on right here. Now remember that you should double check that you can't combine anything at this step here, but I see p squareds, no p, p cubed. None of those are like terms. That is my answer. So I'm looking at number 2. A cubed minus 2a squared minus 3a squared minus 4a cubed. Well, we could use the lining up here because we just have a cubed and a squareds. So underneath this a cubed is going to go our other a cubed. Okay, and underneath our a squared goes our other a squared. And then you do have to remember we are subtracting. Let me screen for that. So subtract. Come on. Okay. Well, what's a cubed minus a negative 4a cubed? First, you gotta remember what is in front of that a cubed that I can't see. The invisible coefficient is 1. What's 1 minus negative 4? Put it on your calculator. Generally speaking, most of us are not good enough with subtracting negatives, adding negatives, etc. to really know what the sign needs to be and what the value needs to be. 1 minus a negative 4 is going to give you a 5. And then remember, it was a cubes and more a cubes. Answer's an a cubed. Okay, we've handled this first section here. Now let's worry about those a squareds. I have negative 2a squared minus 3a squared. So now what we're typing on the calculator is negative 2 minus 3. Negative 2 minus 3 gives me a minus 5a squared. So now I'm looking at number 3. I will get rid of the work here on 1 and 2 so that we just leave the answers. Okay, so you have 4 plus 2n cubed plus 5n cubed plus 2. What you should do now that we've done 2 problems together, especially since we already did notes, is you should pause this video, try to do it on your own, and then just check your answer. So we have 4 plus 2n cubed plus 5n cubed plus 2. Is there anything that can go with my 4? 4 has no variable, so anything that goes with it can't have a variable. Can't be that 2n cubed, it has an n. Can't be the 5n cubed, has an n. But 2 is also by itself. It's another constant. 4 plus 2, 6. Now let's see if those other 2 are going to go together. That would be convenient, but again, you can't assume. It didn't happen on number 1. Two n cubed, 5n cubed. They have the same variable, and do they have the same exponent? Yes, they have that 3 as the exponent. They're both n to the 3rd powers. So let's put them together. Remember, add your coefficients, the 2 and the 5. 2 plus 5 is positive 7. And then keep your variable and exponent. Your answer is 6 plus 7, n to the 3rd power. So we're looking at 4n minus 3n cubed minus 3n cubed plus 4n. This time I'm going to distribute my negative. So it's 4n minus 3n cubed minus 3n cubed minus 4n. Anything that goes with this 4n? Well, you got that 4n. Positive 4n, negative 4n. Those actually cancel each other out. We have no n's. If you need to double check and see why that happened, just type 4 minus 4 on your calculator. You will get 0. 0n doesn't need to be written. 0n doesn't need to be written. Now I have negative 3n cubed minus another 3n cubed. Is that the same as what happened with the 4n's? Is the answer 0? Unfortunately, no, because they're both negative. A negative and a positive will cancel each other, but not two negatives. So if you need to double check on the calculator, you're doing negative 3 minus 3. It's not going to give you 0. You should get a negative 6. And then remember, same variable, same exponent. This next page, entirely the same thing. Just binomials being put together. We can do 9 and 10 together because these are trinomials, right? A trinomial. A trinomial has the prefix tri, like a tricycle, so it has 3 terms. Nothing crazy being added here. You just do it a third time. So let's look at negative 4k to the 4th power. See if there are any other k to the 4th power. Give you a second to look. I see this negative 3k to the 4th. In this case, we are adding. So it's negative 4 plus negative 3. I know it's going to have a k to the 4th behind it. Negative 4 plus negative 3 is negative 7. Okay, took care of those. Looking at positive 14. 14 is a constant, has no variable behind it, so I can combine it with anything that is also just a number, has no variable attached. Can't combine it with that 3k squared, can't combine it with the negative 14k squared, can't combine it with a negative 8. 14 plus negative 8. Positive 6, what's my variable? There is none, so just that positive 6. We've taken care of these guys now. Leaves us with these two, which hopefully can be combined, but again, we can't assume. I see a k squared and a k squared, so I'm good to go. 3 plus negative 14 k squared. Negative 11 k squared. Now I know we're leaving these in not standard form, right? So if you were to try to type this in on any, Photomath or Wolfram Alpha, something like that, to get an answer, it's going to reorder those to be in standard form. Okay, but the commutative property of addition says that these can be in any order we want them to be. And then let's look at 10 together. First term here is a 3. I'm looking to see if there are any other constants with no variable attached. I see n to the 5th, n to the 4th, another n to the 4th, and n to the 5th. It's looking like nothing. Something can't be combined? Still there. 3 is in my answer. Okay, let's look at what's next. What about n to the 5th? Got n to the 4th, n to the 4th, and another n to the 5th. Keep in mind we are subtracting now. What's negative 6 minus negative 8? Negative 6 minus negative 8. If I wrote it out over there, that's your hint to go to your calc. Negative 6 minus negative 8 should give you a positive 2. And then remember, keep everything that's there. We have now used these. Okay. Now I'm looking at a negative 8n to the 4th. I see n to the 4th. Perfect. Negative 8 minus negative 6. So now we are actually flipping those. Negative 8 minus negative 6 this time. Gives us a negative 2. Keep that n to the 4th. Well, now it looks like we're just left with this negative 3n. So I know you're going to be tempted to want to just throw that down there. But unfortunately, we didn't distribute that negative in the beginning. This guy's still in parentheses. We haven't done that. Negative of a negative 3 is actually a positive 3n. That one was a bit more complicated. But again, the actual numbers you're putting together, at most, you just type them on the calculator if they get complicated. Just remember to put the right things together. You never have to complete everything that's in a packet. Obviously, it's recommended, but if there's a couple problems that you're really having trouble with and you haven't had a chance to ask, you can submit something, and then I'll either reach out to you and we'll do them together, or maybe it's something that I've decided, that was a challenge problem, and it's okay if you didn't finish that. And that is the case with the last few. I want to say starting at maybe 26, right? Are those challenges? Because you are adding, you're just adding a third thing in there, but then notice we have UVs instead of just, like a U or a V or a U squared, etc., etc. I will point out UV can only be combined with another UV, right? It has to have the same variables, has to have a U, has to have a V, and both of them need to be with the same exponent. So something like down here, right, where you've got the x cubed y squared, that can only be combined with another x cubed y squared. Can't be combined with like an xy squared or just an xy, something more simple like that. So go ahead and give those a try. If you do try challenge problems, I'm more than happy to give you a little extra credit for those as well.